Okay, the last type of problem people asked about was cross product problems. And so what I'm going to do is I'm going to show the determinant way of calculating a cross product. Sometimes that kind of clicks with people better, but if you prefer the formula that was on the sheet, we'll end up in the same place anyhow. So I'm going to imagine we have some vector v with components v1, v2, v3. W kind of built the same way. Our cross product we can obtain using determinants. If we put I hat, j hat, and k hat at the top, and then in the first row put the first vector in the cross product, that's v. And in the last row, put the second vector of the cross product, that's W. And then we can calculate this using determinants. You can just copy the process if you don't know what that means. If you know what a determinant is, then just go ahead and do it the way you know. But what you do is you take the first entry, and you're going to multiply it by ignoring what's below that entry, that I hat, and then taking the cross multiple of what's left over. So I'm going to do V2 times W3, and then I'm going to subtract the opposite diagonal, V3 times W2. It's going to be impossible for y'all to read later if I use my hand like that. Okay, then I go on to the second component. But I have to add a minus sign because that's how determinants work. Just remember it if you don't know determinants. Again, ignore what's in the middle below what I've just written, j hat, and then take a cross multiple. Here that's going to be V1W3, subtracting the other diagonal on V3W1. And then I go on to the last component. I do my plus k hat. You only have to remember the minus sign for the middle j hat. Block out what's below k hat and then do the diagonal V1W2 minus the other V2W1. And then if we simplify this, it's actually just going to look like your normal cross product formula. I'm going to distribute that minus sign, so I end up with plus V3W1 minus V1W3 times j hat, and my k hat's the same as before, V1W2 minus V2W1. And so if you prefer the formula, just memorize this formula and then you can plug in your numbers. If you prefer the determinant process, then you can go ahead and use that and you'll end up with the same answer. And so we're going to go ahead and just practice this. We'll take V equal to 1, 2, 3. And W equal to 1, 1, 2. I'm going to use the determinant, but if you prefer the formula, go ahead and follow along, do it your way. I'm going to put my V vector first because I want V cross W, so I'll do 1, 2, 3, and then my W because it comes second, 1, 1, 2. And then I'll just start taking my determinants. Again, at this step, you could go ahead and plug in these numbers. But I'm going to get I hat times 2 times 2 minus 3 times 1. Just blocking out that 1, 1. Like that. Minus j hat times 1 times 2 minus 3 times 1 plus k hat times 1 minus 2 times 1. And then if I simplify all that, I'll get I hat times 4 minus 3 is just 1. Do it like that. Minus j hat times 2 minus 3 is minus 1. Plus k hat times 1 minus 2 is again minus 1. Or I'll go ahead and write it back in these angle bracket formulas so we can kind of see how those are the same. Just good practice. I had a 1 in the I component, a minus 1, so that's a plus 1 in the j component, minus 1 in the k component. And if you followed through using the formula, hopefully you ended up in the same place. The cross product v cross w is 1, 1, minus 1. There's a couple properties of cross products that we used. The cross product between two vectors is the area of a parallelogram formed by them. So if that's v and that's w, the magnitude or length of v cross w is the area of this parallelogram I sketched. A vector normal to that parallelogram, orthogonal to it, perpendicular to it, is going to point in the same direction of v cross w. And those properties will come back. This one in particular much later. So just remember how to compute the cross product and you'll be ready when we use it in the next exam.